Good morning. My deep learning project topic is Alzheimer's detection using deep learning. My contents having introduction, dataset, CNN architecture, training and validation result, comparison with other models or methods, and lastly conclusion. Introduction. Alzheimer's disease is a progressive neurodegenerative condition that affects the brain and causes memory loss. Memory loss can be considered as the early sign of Alzheimer's detection. If we are able to analyze Alzheimer's during early stages, we can give treatment early to a person and which can help to cure permanently from the disease. So, this Alzheimer's detection is an important thing in our daily healthcare sector. Here, Alzheimer's is identified by using convolutional neural network. And effective convolutional neural networks are mainly used for detecting image analysis like Alzheimer's detection or image classification task anything. The main use of convolutional neural network is the analysis of patterns or feature extractions from the similar or similarly images and give classification to these images. Next about dataset. I downloaded the dataset from Kaggle and my dataset is having 6400 images in total, and among these I split the data into training and testing, and for 5121 images I used for training and 1279 images I used for testing. And in my dataset there are having 4 classes: mild dementia, moderate dementia, non-dementia and very mild dementia. Next is CNN architecture. CNN architecture is a network designed for deep learning that learns directly from data. The use of CNN are object detection, or which are can be any time series, signal, audio data, or which are highly useful in our daily life. The minimum criterion for a network should be a convolution neural network. It should having input data, hidden data, and output data. Input data, hidden layers, and output layers. If it's having only one hidden layers, it is similar to deep linear regression model. So there should be minimum criteria for a convolutional neural network. There should having minimum 2 hidden layers. So input layers, hidden layers, and output layers. In convolution neural network, there are different layers. The explanation of different layers can be in input layers, and this is the first layer where raw input data is set to be processed, and which would be pictures pixels in an image classification job. Next layer is convolutional layer. The convolution layer uses a number of filters to extract information from input pictures. And next thing is ReLU layer. ReLU layer is actually, it is not a layer, it's an activation function used in convolutional neural network, and ReLU sets all negative values to 0, which makes the output more spaced and simple for following layers to analyze. Next is pooling layer. Pooling layer downsamples the output of ReLU layers to picking the maximum value from the set of value which is given from the ReLU. As a result, data dimensionality is decreased and model become more resilient and little changes to input. Next is dropout layers. Dropout layers are most commonly used when there is overfitting issues will occur. These dropout layers decreases the overfitting issues, and which are commonly used for in the case of fine tuning. We are commonly use dropout layers. Fully connected layers. These layers are take output of the layer. Output can be occurred from these fully connected layers and appears as linear transformation followed by an activation functions. The most commonly used activation function is softmax during in fully connected layers to create a network a final output. In a CNN, the output layers is the last layer which generates the model's final output, and the probability distribution across the many classes in picture classification jobs might look like that. Training and validation result. These are the images which I had given as input, and which this is randomly visualized some images, and it having no dementia, very mild dementia, and like that. Actually, I have 4 classification, only 2 are visualized here. Training and validation. These are the main steps in CNN architecture. Here I took 5021 images for training, and these training I split the training data and put it in a sequential model, and the corresponding I got 89% accuracy. After that, I fine-tuned the model by changing some layers of the model, and in addition to make some dropout layers, and to make changes in regularization. And after that, I got accuracy of 93% for training data. And in case of validation data, I got accuracy of 86%. And overall, and hence I can understand that overall performance of my model is very well. In fine tuning, number of approaches I increased to 100. Before fine tuning, my approaches count is 15, and after that, I change it to 100, and the learning rate changes to 0.001, and hence accuracy increased. Here is a pictorial representation of training and validation accuracy before and after. The one in red color shows the fine tuning accuracy, and in blue color shows the accuracy during first evaluation. Next is the important part is deployment. Deployment is the method deployment during training process. We got a model.hy. We saved it as model.hy during our execution of the code, and after that, by using this model, we are deployed our model or in a real life scenarios. We are using our model used for a real life scenario. Here I am using my model for analysis of Alzheimer's, and by giving input to the model, and I try to analyze with the given MRI image is related to which stage of Alzheimer's. Here the model downloaded from Colab is given to Visual Studio in addition to the template and application Python file. Then I give my local address to the Chrome, and in corresponding to that, an index file is generated, and I uploaded the test image, and I get correct predictions in accordance to the input images. Then comparison with other model. There are several models available such as RNN, Deep Belief Neural, but among all these, CNN is the best of Alzheimer's detection of medical images. I actually tried VGJ16, VGJ19 Inception V3, and ResNet 50, but all these are giving very low percentage of accuracy, like 50, 60, like that. But I'll consider convolutional neural network, I got accuracy above 90%, without much overfitting issues occur while getting this accuracy. Conclusion. In recent study, application of convolutional network Alzheimer's detection using MRI images has shown significant potential. The ability of CNN to learn the intact details of brain MRI pictures and categorize them as healthy or disease can be demonstrated. For patients' treatment outcomes and quality of life, early diagnosis of Alzheimer's disease is essential. Early diagnosis of Alzheimer's disease using CNN has a potential to be considerably improved, enabling the early intervention and treatment planning. In conclusion, the application of CNN for Alzheimer's identification from MRI scan is a promising area of study with the potential to have a huge influence on the lives of millions of individuals throughout the world. Thank you.